Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 6, questions 18 to 20. And in this unit, we're going to take a look at some immunology. Well, it is watered down immunology, but it's still important because we're just going to discuss helper T cells. Now, helper T cells are probably arguably one of the most important cells in adaptive immunity because they can also help signal B cells and cytotoxic T killer cells to kill antigens. Or in this instance, well, ACER tells us that an antigen is just any substance that stimulates an immune system response. So, in this unit, ACER was being a bit funny. They did it on purpose. I mean, the figure they give you is useless because it doesn't actually tell you what's happening, which is why I kind of drew, I guess I gave a nice summary here of the helper T cell activation and immune response. Whereas in the unit figure that ACER provides, it's just showing you the helper T cell at rest. It's got its IL-2 receptor and the IL-2 molecules that can bind to the receptor. But what actually happens, let's say, at rest, we have an antigen that can interact with our resting helper T cell. What that does is it stimulates the helper T cell to increase IL-2 receptor production on its surface and to increase the secretion of IL-2. Now, the reason why that's important is because IL-2 can bind to, say, other T helper cells that are complementary to the antigen. Remember that. So the antigen, the T helper cell has to be complementary to the antigen. It can't just be any random T helper cell because remember it's supposed to be adaptive immunity, so we're supposed to be targeting a specific antigen. Because if the IL-2 was binding to and activating any random helper T cell, you'd kind of elicit this immune response that can degrade anything in the body. We want to target the antigen, so it has to be complementary to the antigen. So IL-2 binds to the complementary helper T cell, and that stimulates the division of the T helper cells that's specifically to complementary antigen. So we can divide, and it's kind of like a doubling process. One divides to two daughter cells, what it tells us in the stimulus. Then those two can divide to four, then to eight, and it keeps doubling, doubling, doubling. Just note that the antigen as well can again stimulate one of these helper T cells to divide, and the process keeps going until we build up a large amount of helper T cells, which can then obviously elicit a response in B cells and cytotoxic T killer cells. So that's a kind of nice summary of what's happening. So if we take a look then at question 18, it's saying which of the following is most likely to best represent the initial proliferation of the helper T cell activation or T cells in response to their complementary antigen. So remember what we said, it kind of says it there in the text as well. It says that division of T helper cells produces two identical daughter cells. So we're going to get for every one, we're going to get two. So then that's going to give us two, that's going to give us two, and then it's going to keep doubling. So it's the same principle. So what that means then is, if we take a look at the graphs, so the first graph, A has a linear line. That's wrong, because linear line means that's a one-to-one, which means it's just one goes to one goes to one, or, you know, it's the same idea. So it's just going up linearly. So that answer is going to be incorrect. B goes like this. Well, that's not true because it's suggesting that at the top it's going to plateau, but there is no suggestion here that the T helper cell proliferation plateaus. It just keeps getting bigger. So B is going to be incorrect. C, well, C looks correct because we see it's kind of this exponential growth which we're describing. So it keeps doubling, 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 doubling. So we can see that. That was a nice game, say doubling a million times. But you see it just keeps increasing and increasing. So C looks correct. We'll tick that for now. D kind of has this linear increase and then bang, it shoots up. That's not how it works because we can see it's this doubling gradually. So it's this kind of exponential. It's not like it goes up and then bang, it shoots up because the exponential growth it's kind of a constant exponential growth. So it's not like it's changing. So that's why D is incorrect. So the answer has to be 18 is C. So if we take a look then at 19, I'll clear the screen here. 19 asks, which of the following best explains the value of process described? The process allows a rapid increase in the number of. So we can see straight away the most important thing in an immune response, if you have to think about the big picture, we want to produce as many helper T cells as possible so we can stimulate the B cells or the cytotoxic the killer T cells. So the most important thing is we want to increase our helper T cells. So the answer can't be A or C. So the IL-2 and the IL-2 receptors are just to increase the number of T helper cells or the helper T cells. So it's either B or D. So is it going to be a helper T cell or is it a helper T cell complementary to a specific antigen? Now remember what we said at the beginning. We want to make sure that we increase the helper T cells for the specific antigen because we want to elicit an immune response to remove what is causing this antigen or to remove this pathogen. Because if we just activate any helper T cell and we generate a massive amount of helper T cells for any other antigen or any other thing in your body, it's going to cause, an autoimmune disorder. It might destroy your body itself. Like, for example, say rheumatoid arthritis and these sorts of pathophysiological conditions where you're going to destroy your own body based on the fact that you're not targeting the right antigen. So in this instance, it has to be complementary to the specific antigen so we can minimize damage to your own body. So the answer, therefore, has to be for 19 is D. So the last question here, last question 20 states, which of the following would most likely inhibit the division of T helper cells? Now, if we take a look at the options presented, so let's take a look at A. So A says inducing resting T helper cells to express IL-2 receptors prior to activation of antigen. That's not true because if you just express IL-2 receptors before activation of antigen, what happens is once the antigen binds, so remember, once the antigen binds to the resting T helper cell, it actually stimulates IL-2 secretion, and that can bind to the IL-2 receptors to activate a response. So whether or not you add IL-2 before or after, it's not going to make a difference. So A is incorrect. So B, injecting excess IL-2. Well, that's actually going to activate division of Th cells because remember, IL-2 binding to the helper T cell stimulates the proliferation. So B is going to be incorrect. C says injecting excess unattached IL-2 receptors. Well, that's actually true because if you think about it, if you're just going to attach IL-2 receptors in the system but not onto the actual helper T cells, the whole point of the IL-2 receptor is once it binds the IL-2, it stimulates the helper T cell to divide. But if you're not going to have the IL-2 receptor on the helper T cell, you can't actually stimulate the division or the production of daughter cells. So C is kind of correct. So we'll leave that for a second. So D says increasing the number of IL-2 receptors on the T helper cells. Now, again, increasing the number of, it's kind of like A is the same as D actually, it's the same thing. If you're going to increase the number of receptors on the helper T cells, you're going to actually facilitate more or will facilitate IL-2 binding to the receptor so you can stimulate the division of more daughter cells. So D is going to be incorrect. So the answer has to be C. So with these sorts of immunology questions, I mean, this one was a bit tame, but I know they can get a bit more difficult for ACER. It depends on the graphs they show you because there's a lot of immunological factors. They might have included as well B cell activation or the cytotoxic T killer cells. But just note that if you just have a background in immunology and note that in adaptive immunity, I guess if you want to go back and study, make sure you know adaptive immunity and innate immunity, the differences between the two, and know them back to front. Because if you do know these back to front, answering these sort of questions will be pretty straightforward. So if you do have any more questions about this unit, you can post your comments in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.